Okay, so now we are on 4.2. So 4.2 is on graphing polynomials. 4.1 and 4.2 are all about polynomials in general. A polynomial is a smooth curve. So maybe let's go over that. Polynomial. A polynomial is going to be a smooth curve. And it goes all the way from x is positive infinity to negative infinity, or vice versa, whichever way you want to look at it. But the domain, what that's saying is that the domain is all real numbers, every x from negative infinity to positive infinity, and that is for every single polynomial. Smooth means once you start a curve, you don't stop, you don't make jerky movements, you just whee. Okay, so that is a polynomial. What polynomial? I have no clue, but it's an example of a polynomial. It's a smooth curve that goes, it might go up and down, but there's no hard corners to it, right? It's not like that. That would be like an absolute value. There's no cusp, one that maybe goes down and then back up, right? That is not allowed. It doesn't have anything to do like that. It doesn't stop and then start. Okay, it doesn't do maybe. So that's part of a polynomial, and that's part of a polynomial, but together, see, there's separation. That would be a piecewise function, right? Well, it's not a polynomial, but this is a piecewise function. Okay, so a polynomial is smooth, and its domain is all real numbers, everything from negative infinity to infinity. So now let's look at something to do with the degree. So if it has a degree of n means your leading term. It means that your leading term looks like this, a x to the power of n, okay? So if it has a power of n, the highest power is n, then it's going to have n many zeros. And what does that mean for the x-intercepts? Is it going to have n x-intercepts? No, because x-intercepts are only the real zeros. So it's going to have at most n x-intercepts. Okay, at most n x-intercepts. So it could have n minus 1, n minus 2, etc. And then turning points is the numbers, a number of maxima and minima, and it's going to have at most how many? Well, think about it. Let's look at a parabola. A parabola is an x squared, right? And a parabola looks like this. Every single time a parabola looks like this. And how many maxima or minima does this have? 1. It has 1 minimum. What about x cubed? An x cubed could look like this. How many maxima minima does that have? 1, 2. So if our degree is n, and this is the number of maxima or minima, degree of n, maxima minima, what's the relationship here? The relationship is if this is n, this is just minus 1. N minus 1. So we have at most n minus 1 turning points, okay? So an example would be a polynomial of degree 6. If your degree is 6, then it's going to have 6 zeros. They might not all be distinct. They might have repeating zeros, but it will have 6 zeros. So that means that it will have at most 6 x-intercepts. Maybe it has 5, 4, 3, 2, 1, 0. Okay, but it's going to have at most 6. How many turning points? Well, it'll have at most 6? No. 5. Why 5? Because it's 1 less than the degree. So let's look at possible shapes of a polynomial with a leading term of positive 5x to the 6th. Okay, so we just did one with the degree of 6, and now we're looking at one with the degree of 6. Okay, so all of these things still apply. Has at 6 zeros, at most 6 x-intercepts, and at most 5 turning points. So in this question, we are going to look at the number of turning points using the fact that it has at most 5 turning points. So here, turning points, I'm going to abbreviate as TP, And with this whole coronavirus thing, everything you see with TP is usually toilet paper, but we're going to call it turning points. So maybe that'll help you look at some of those memes that you've been seeing and think of TP as turning points. Remember, this has one turning point. So can this describe, could this be a possible example of this polynomial? A polynomial with a leading term of positive 5x to the 6th? No. Why not? Because, think about it. Let's look at part B. Part B. This also has one turning point. Can this be a possible graph of a function that has a leading term of positive 5x to the 6th? And the answer is yes. What is the difference between this one and this one? What about your leading coefficient? What is your leading coefficient? The leading coefficient here is a positive 5. And what does the leading coefficient tell you? The leading coefficient, positive or negative? The positive tells you that the right end behavior does what? Positive means goes up. And this right end behavior goes down. And that is why this is not a valid graph. This one is a valid graph because it goes up. So now let's look at part C. Part C, we count how many turning points? Well, we have a minima, a maxima, a minima. We have 3 turning points. So 3 is less than 5. So yes, this could be a possible graph. Now D, that has a lot. 1, 2, 3, 4, 5. 5 turning points. Can this be a possible graph? Yes. Has a end behavior that goes up, has 5 possible turning points, so yes. Now, I couldn't fit this on my paper before I took a picture of it and saved it as PDF, but I wanted to include a part E. What about, I don't know, I'm just drawing. What about something like this? Well, the answer is no. Why? Because how many turning points does this have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 turning points. Okay, so this is not a 5x to the 6th. 5x to the 6th question mark? Absolutely not. So the question that I want to ask you is, what is the least degree that could maybe describe this graph? That's a bad way of saying it. But what's the leading term going to look like? So the leading term here would be it'd be a positive leading term, right? It's going to be a positive leading term. Now, what's the minimum degree that it could possibly be? What's the least degree that would describe this graph? Well, the degree is your highest exponent of your polynomial, right? And we know that the highest exponent, that degree minus 1, is the most number of turning points. And since this has 9 turning points, our degree would have to be 10. So an example of a leading term for this polynomial of this graph would be a positive something x to the power of 10. Okay, it's going to be positive because our right end behavior goes up. It's going to be to the power of 10 because it has 9 turning points. Now, could it also be 10x to the 12th? Positive x to the 12th? Yes. It could also be positive x to the 14th. Okay, why? Because the number of turning points has to be n minus 1. So number of turning points here would be 9, 11, 13, but that's the most number of turning points. Okay. Okay. Let's go to the next page. Okay, so this is the handout that I have online, by the way. I put it on Blackboard. So here we have steps to graphing a polynomial function. This is a really actually good place to stop because now we're at 10 minutes in the video.